Hello, my name is Advith Krishnan and I'm pursuing the project RAG to Riches using your legacy data. I am a Linux Foundation and Open Mainframe project mentee, and my mentor is Dr. Vinu Viswasadhas. To start off, I will set the premise of the project and then I will go over my midterm and final term contributions for my mentorship. So, to set a premise of this project, mainframes are used in a wide range of fields, be it in banking, be it in large infrastructures, uh, organizations that rely on a huge amount of systems that need zero downtime, but at the same time, they need to be able to handle a huge volume of data transfer, whether it be via transactions, whether it be via data replication, and the use cases are abundant for mainframes. But the problem is when you have a system that has a large number of different pipelines, lots of data replication pipelines happening, lots of different data transfer pipelines, data modification and transformation, you have a huge infrastructure to deal with. And in such a case, if insights need to be drawn with respect to trends of the system at large, or if there is a problem within the system where you want to identify the root cause of the problem, the issue of the problem, in some organizations it can be seen that there are hundreds of different pipelines to go through, and it is just too cumbersome of a task, even among seasoned engineers. And there is also the accessibility gap where teams with different skill levels, different roles, they have access to different parts of the system, and only very few have access to the system as a whole. So understanding context across different systems and within systems becomes a bit of a problem. Now, perhaps a user wants to know why their login service is degraded, or they want to know whether if some user sessions are at risk based on different input-output trends, or they want to identify anomalies. Mainframes can solve this because they have shined in these scenarios. And in these scenarios, mainframes can actually perform because they have shown to provide zero downtime at the same time with high volume data transfer and data processing. Now, for my midterm, I had discussed with my mentor, Dr. Venu, and we had come up with a pipeline where we use a user prompt, we pass it into a query understanding layer so that we understand what the user is asking, what problem they have, or what do they want to know. And the query planner will basically generate a plan. This can be, if need be, to query from SQL or no SQL database, or if they want to learn something about the system at large, or they want to retrieve certain logs. So the query planner will basically chart out the plan and design the system instructions for that. Then we use role-based access control to control the data retrieval and data transfer of the user. And we have two stages of retrieval. One is a level 1 retrieval, which is done via vector knowledge graph, since they are known to shine in showcasing context and relationships within context and across context. So these can be really helpful. However, it wouldn't be viable to transfer every data of every data source into a vector knowledge graph. So we employ this level 1, level 2 system where we only add vector knowledge graph based on a need basis. If there is a need for it and someone has already queried this related query, we use this framework to not only generate the relevant context needed to solve or needed by the user, we also store the user prompt and response in the vector knowledge graph in the scenario of someone else needing the same type of data, same type of context about the system. If that question has not been asked before, we do a level 2 retrieval where we do a deep actual query from structured DB, from mainframe logs, from SQL DB, from unstructured data stores like GraphQL. It can also be from Pinecone or PG Vector, vector databases. You name it, we can basically expand this framework to different types of data sources via our data base connection layer. And we all unify all this data into this one unified vector store, and we pass it into the RAG engine and we provide it via response. Now MCP is also an option where we can perform summaries, perform actions, maybe provide notifications on Slack or different platforms, or provide plots, and the possibilities are endless with this framework. Now for the final term, we had to move to implementation of this framework. We ran into a little bit of a snag where we identified a huge variety of use cases for this, and this led us astray a little, but we ended up focusing our efforts to at least getting a demoable or an implementable version of this, and so that we can focus on expansion after the framework is validated through implementation. Now, as you can see, the same steps as shown before are presented before you, where you have a user input, you have a query understanding layer, a planning layer, you have the type 1 retrieval, which we use Neo4j as the vector knowledge graph for this. And then we have a type 2 retrieval, which is the DB connector, where we connect PG vector, we connect PostgreSQL, which we are using as a proxy to emulate mainframe data, just for the demo sake. And then we also provide Splunk as an option, and then this all unifies within the RAG engine, and we provide it as a response, and at the end, very end, we have the VKG update. Now another thing to point out is that this was implemented via open source framework called N8N, which is a low code platform that can help implement agentic and RAG frameworks. Now, as part of the project that I am working on, I am to deliver a white paper on this as well, where I will introduce this framework as a new novel framework that we can implement within businesses, within organizations, and so on. That concludes my contributions for the Open Mainframe project, and I would also like to acknowledge my mentor, Dr. Vinu, and I would also like to acknowledge the Open Mainframe project for giving me the opportunity to work on this project. Thank you.